So there's going to be no WebAssign on gamma decay as well as decay chains. However, I do want to go over them because in the next 2-week block, we are going to look at some fission and fusion chains. Those are reaction chains, not decay chains. And so this will just give you a little bit of an overview of what it is. Gamma decay is very simple to do. So gamma decay on uranium-238. Uranium is the 92nd element. The uranium will yield gamma plus 238.92U. Didn't actually turn into anything else. So the question is, well, what's the point? The point is, in more complex physics, we would talk about this gamma in more detail. We would talk about how much energy was that. So if you remember in the electromagnetic unit, electromagnetic waves, we talked about electron energy levels, and we had like n equals 1, n equals 2, n equals 3, n equals infinity, and we talked about, well, an electron at this level could drop down to here, or it could from this level drop down to here, or from this level drop all the way down. It didn't change the atom, and it did not change whether it was an ion or not. It was the same atom, the same number of protons, same number of neutrons, same number of electrons. But the result of all of these was the emission of light. So maybe this low energy one shot off red light. This medium energy one shoots off green light. This high energy one shoots off violet light. So the result of the electrons dropping into lower energy levels was the emission of light. It could be a different color of light. It could have been X-ray. It could have been ultraviolet. It could have been infrared, so on and so forth. What this is talking about is the emission of light. In particular, the light that's emitted is gamma radiation. So just like electrons have energy levels, the nucleus itself can be arranged in various energy levels, higher and lower states. Let's go through a decay chain. So you'll also notice too, I don't do the neutron count on this. I only did that for WebAssign. Normally I don't bother with the neutron count. I accept the fact that 238 minus 92, I mean that's a number. If I cared to know how many neutrons there were, I could solve. I just think it's a redundancy, but whatever. Okay, so we're going to do a decay chain, and we're going to start with uranium-238. Uranium's the 92nd element, and the first decay is alpha. So alpha will give me 4,2, which is helium. The results will be 234.90. And if I check the periodic table, which, wake up mouse, there we go, 90 is thorium, TH. So come back here, thorium. Now the decay chain takes the new nucleus, the daughter nucleus, which in this case is thorium-238, and it just continues to run through with your new nucleus. So this would be 230.88. Come back to the periodic table looking for number 88, and 88 is right here, radium Ra. So we'll go Ra. To start the next line of the chain, I'm going to use that 230 radium. Should be an A. We undergo a beta decay, so that's 0, -1 E, or if you want to use the beta symbol too, that's fine. 230, 89, because 88 equals -1 plus 89. Periodic table. Number 89 is actinium, AC. Our next line on the decay, I'll have to scroll down a bit. 230.89 AC. We undergo gamma. This is very easy then. Our nucleus is still the same nucleus. That's my gamma. Last one's an alpha decay, so I'll start again. 230.89 AC yields the alpha particle, 4,2 helium. This will give me 226.91. If you come here, 91 PA. And just like that, I have completed the decay chain. Smiley face. Eyeballs. Perfect.